In this lesson, we're going to look at the arcs and the angles formed by intersecting chords. So, in this circle, let's draw a pair of chords which intersect. And when they intersect, they form a whole bunch of angles here. We have this angle and this angle, which are vertical, so they're equal. We also have this angle and this angle, which are vertical, so those are equal. And we also have a number of arcs that are formed. So we have this arc, and we have this arc. Okay, these are not equal. These are not the same length, okay? Even though that the arcs, the angles across from them are equal, these two are equal, these do not equal each other. And likewise, we have an arc here, and this arc. These also do not necessarily equal each other. This angle and this angle are equal to each other because they're vertical, but these angles are not equal to each other. There is, however, a relationship between these angles and the arcs. So, for example, let's take a look at these angles and these arcs. Okay, let's say the measure of this arc is x degrees, and the measure of this arc is y degrees. And we'll just say the measure of this angle is a degrees. This one's also a degrees, but we'll just label 1. Well, what we have is this angle is not necessarily the same as this arc, and this angle is not the same as this arc. What we do have, though, is that angle A is equal to the average of the two arcs. So x plus y divided by 2 will tell us what this angle is. And we can do the same for these angles. These two angles are the same. And we have these arcs. So we say this angle is b degrees, this is w degrees, and this is z degrees. This angle b is going to be the average of these two arcs. So this arc plus this arc divided by 2 tells us how big this angle is. In this example, we have the measure of 3 arcs, 80 degrees, 90 degrees, 70 degrees, and a missing arc. And we also have to find out what these angles are. So when we look at this, we see that this angle A is the same as this angle, and these angles intercept this arc and this arc. So that means A is the average of 80 and 70. So we have A equals 80 plus 70 divided by 2. We end up with A equals 150 divided by 2. So we have the measure of angle A is 75. Okay, next we could find C. We know that all our way around, all of these arcs have to add up to 360. So we have 80 plus 70 is 150, plus 90 is 240. So we can solve for what C is. Just do 360 minus the 240 already accounted for. We get that C is 120. So now B, which represents this angle, and likewise is the same measure as this angle, intercepts this arc and this arc. So B is the average of these two. So we have B equals 90 plus 120 divided by 2. So we have 210 divided by 2. We end up with 105. So B is 105 degrees. Something else you might notice is that this chord is a straight line. So that means these two angles have to add up to 180 degrees. So if we were to check it, we would just have 105 plus 75. We get 180. So we could use this as a backup to check. So this is an example of a question we could have that involves intersecting chords, the measurements of their arcs, and also the measurements of the angles formed.